if you are going to follow along in your book. So we're talking about functions. So it's basically kind of just another way to write a two-variable equation, but it has kind of a more specific definition. So a function is just an algebraic relation where only every number that you put in, so every x that you plug in, is only going to give you one specific y value. Right? So if you plug in 1 for x, you should only be able to get one specific y value for it. You shouldn't be able to get two answers for the same x, if that makes sense. One of the ways that we can list functions or describe functions is by a list of ordered pairs. So, for example, let's say we have -1, -1, and -1, 0, and 0, -3, and 1, -1, 2, 5. So, rather than being actual coordinates, you can think about it that way. So, we're just saying that there's some function that where if you plug in -1 for x, you get 1 for y, right? So it's you're plugging them into an equation, basically. And these are just so this is what you put in. So these first numbers are your inputs. Which is also your x values. And then the second ones are the outputs, which are your y's. So to tell if something is a function by just looking at this set of ordered pairs, you really only need to look at the inputs, right? So if you have the same input, right? So look here, for example. So these first two, they both start with -1, but we get two different outputs. That's not possible with the function. Right, so if you have basically the same x value anytime, you can instantly say that this is not a function. Right, so there can only ever be one x for the same, or one y for each x. So an example of one that would be a function then would be, I'm just going to make stuff up. Right, so would that be a function? Yes. Right, because look at the x values. So there's a 1, a 0, a 2, and a -3. Right? So none of them repeat. So if you have any repeating x values, it's not a function. If they're all different, then it is a function. Does that kind of make more sense that way? So this one is a function. All right, and then the other way we can determine if something is a function is by looking at its graph. Right? I'm not asking you to graph anything. We're just going to look at a picture of a graph and be able to determine if something is a function. All right, so can I go to the next slide? Okay. So let's say that we have, I'm going to draw a couple different graphs of things here. And let's do one more. So let's say we have a parabola So let's just say we have pictures of graphs, right? And you would be given these ahead of time. So to determine if something is a function just by looking at the graph, we're going to do what's called the vertical line test. And basically that means that if at any point in the graph, like if we can draw a vertical line through it, if it's going to touch the graph at more than one point, then it's not a function. So like for this first one, if I like were to draw lines, like anytime I draw a vertical line straight down, it's only going to touch my red function at one point, right? It's not ever going to cross, the same line is not ever going to cross that graph at more than one point, right? And we're only drawing vertical lines, like straight up and down, right? So then same thing in this other one here. Again, it's only going to cross my red function at one point with a single line. But then in the one down below, look, I cross 1, 2, 3 times. Right, so this one would not be a function, but these two up here would be. So you basically just have to like draw lines on the graph, and if it touches it, if any one line touches it more than one point, it's not a function. Right, so is that kind of straightforward enough? Okay. Then the last thing that we really need to go over in this section is evaluating functions. So the notations looks kind of like, well, it looks like this. So it's like, we read that as f of x, and then it's like an equation. So basically, it looks scarier than it is, first of all. This is just another way to like write y, basically. It's just saying a function of x is equal to this equation or expression. So when we are evaluating functions, it'll tell you to evaluate the function at, let's say, 5, right? We want to know if we plug in 5 for x, what we're going to get. So like when you see something like this, all that's telling you to do is plug in 5 wherever there's an x and like work it out. So like this would be 3 times 5 plus 2. Right, so then this stays the same. This f here is not a variable to solve for. It's just telling you that a function of x at 5.
Where did you get 5?
You will be told specifically to plug a certain number in. Right, so you would be told to evaluate it at 5. I could plug any number I wanted in here. I just picked the 5. So then we get 15 plus 2, which means that it's equal to 17. So that means that the function value at 5 is equal to 17. So basically that means that if we wanted to like graph that line, that means there would be a point that's at 517, is all it means. Right, so we're plugging in x values to get our y values, essentially, is what we're doing. So we're plugging in and simplifying. Like if you look at the examples on page 177, right, there's quite a few there. So like let's look at that first one. So like in part A, it says f of x is equal to 5x squared minus 4x plus 3. It wants us to evaluate it where x is negative 3. So what that means is we're plugging in negative 3 for x. Right, so we're going to have 5 times negative 3 squared minus 4 times negative 3 plus 3. Right, and then we're basically just using our order of operations. So we're going to do our exponent first, right? So negative 3 squared is a positive 9. So we have 5 times 9 minus 4 times negative 3. So that's going to be 45 plus 12 plus 3, which would equal 60. Right, so that just means that our function value at negative 3 is equal to 60. So we're plugging in numbers. Okay. Does that make sense to everybody for the most part? Okay. All right, let's just do one more example really quickly. Yeah, we'll do one more real quick, and that would be it. So let's look at part B there. So it says g of x is equal to x minus 4 over 2x squared minus 3 at x equals 7. So again, that just means we're plugging in a 7 for x and simplifying. So we're going to have 7 minus 4 over 2 times 7 squared minus 3. So 7 minus 4 is 3, and 7 squared is 49. Right, and then 2 times 49 is 98? Yeah, 98. Right, and then so we get 3 over 95 is our answer. That's it. There's nothing sneaky today. It is nice. All right, so there is no homework tonight. We'll do the assignment for this section on Monday. So if for some reason if for some reason we would not be here Monday due to snow, this is what we're going to be doing the assignment on. And don't worry about taking your books home. I'll post a picture of the pages in the book that you need. That way you would have it. Just take your notebook home. That way you can at least do your homework in it and have your notes to reference.